Hello, this video is going to explore the energy cost involved in the creation and distribution of a 15-minute online video. We're going to be breaking down the energy cost into three primary components of video creation, network and distribution, and running the cost of data centers used to distribute the video. This breakdown involves a first-order approximation using the conditions of an amateur video creator using a all-in-one webcam and a multi-purpose PC that was made in roughly 2018. While the first-order approximations are not accurate, they are helpful providing estimates within an approximate scale of what might be true. Additionally, the method should be clear enough that the estimated values can be adjusted to apply to other situations without much challenge. When creating the video, the creator will need a camera and microphone. I chose to use the Logitech C920 as it is a cost-effective all-in-one device. The documentation for the Logitech C920 provides the power usage of the device to be 35 watts while recording. If it's assumed that twice as much footage is recorded than ends up in the resulting video, the estimated energy use should be approximately 63 kilojoules. Most of the energy cost in editing is in powering the CPU and GPU of the PC during the editing. I've chosen to use an Intel i5 for the CPU and an NVIDIA RTX 270 as the GPU, as these are the components that I have on hand. Monitoring my hardware during editing processes, I found that the power load of these components tend to fluctuate between 10 and 35% of their peak functioning capacities. To simplify, we'll assume an average load of 20% of peak functioning capacity is used during the editing process. Editing tends to be more time intensive than recording, so I'm going to assume that the editing process will take 5 times longer than the runtime of the finished product. With these assumptions in place, the CPU takes approximately 112.5 kilojoules and the GPU uses 157.5 kilojoules. All told, the estimate energy cost for creating a 15-minute video is 330 kilojoules. After the video is created, it needs to be distributed. From Marinick and Foster's 2016 paper, when they've used a mid-range router, it took approximately 64.8 kilojoules of energy to transfer 1 terabyte of data. An upload to a data center like those owned by YouTube will be directed as a one-way transfer, and so a 15-minute video having an approximate size of 450 megabytes would take approximately 0.0292 kilojoules of energy to upload. Streaming, on the other hand, can happen at a variety of qualities and bit rates. Assuming a viewer only uses a video quality of 480p at 30 FPS, YouTube uses approximately 9.5 megabytes of data per minute. With that information, a single view of this video would only use 0.092 kilojoules of energy. Even if that video gathered hundreds of views, we can see that the energy cost of sending the data is insignificant in relation to the energy cost of recording the video. Lastly, we will consider the energy usage of the data centers themselves. These data centers must be functioning at all times for the online content to be available to users in the first place. Networking accounts for only a small fraction, approximately 3% of a data center's energy use. The other energy costs are primarily used in cooling, storage, and the running and functioning of the servers. Determining the energy impact of a single video may be impossible, but using the global data of data centers will allow us to estimate the base estimate for the energy consumption that an individual user may be responsible for. It is estimated that the global energy use of data centers in 2022 was 110 terawatts. That's only about 0.4% of the global electricity usage. If one were to assume that the 5.3 billion users of the internet were to be responsible for an equal share of that energy use, then a single user's energy use from the data centers would be approximately 74.7 megajoules per year. So we can see that the largest energy cost of online video creation and distribution is the functioning of the data center itself, where only high levels of video content creation will actually consume enough energy to constitute a significant portion of energy for these online videos. If we use an example of a dedicated creator who makes a video every 2 weeks, the total yearly cost of making online videos is approximately 83.5 megajoules per year. Now, a number means little without context. I'll compare this energy usage with driving, which accounts for nearly a third of an individual's energy use. Using the energy density of gasoline and the fuel efficiency of a vehicle, we'd be able to find the equivalent of how far we would be able to travel on 83.5 megajoules of energy. Gasoline has an energy density of 34.2 megajoules per liter, and North America's most popular sedan, the Honda Civic, has a gas mileage of approximately 7.7 liters per 100 kilometers. The 83.5 megajoules used to create this video would move a Honda Civic approximately 31.7 kilometers. Or, from another viewpoint, a full year of video creation and distribution uses slightly less energy than the average of a single day of commuting for a Canadian citizen.